Chapter 5, Section 6, Inequalities in one triangle. The first property is the comparison property of inequality. If A equals B plus C and C is greater than 0, then A must be greater than B, because that means that A is broken up into two parts, so it must be bigger than this part if C is not 0. If C was 0, then they could possibly be equal, but since C is greater than 0, A must be greater than B. So a corollary to this would be the triangle exterior angle theorem, which we've said in the past. The measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So we've done that 3 plus 2 equals 1. Now we're saying if 1 is an exterior angle, then the measure of 1 must be greater than the measure of 2, and the measure of 1 must be greater than the measure of angles 3. Which makes sense because neither angle measure can ever be 0 degrees. It has to be greater than that. It has to be a positive number, which means if they add up to 1, 1 must be bigger than each of them. Theorem 5.10 states that if two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. We've also seen a little bit of this. So let's say that line segment XZ, the measurement of it, is greater than line segment XY, so XZ is bigger than XY. That means the measure of this angle must be bigger than the measure of this angle. Notice we didn't put lines above the letters because we're talking about their measurements. Theorem 5.11 states that if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So just the reverse of this. If these two angles are not congruent, the side that's bigger lies across from the angle that's bigger. So since A is bigger than B, that means that BC is greater than AC. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle are greater than the length of the third side. So in order for it to be a triangle, you have to be able to add up the sides of the triangle, and it must be greater than the third side. And it has to work for all three possible options. So these two must be greater than this, these two must be greater than this, and these two must be greater than this. It has to work for all possible options. So a triangle has side lengths of 4 inches and 7 inches. What is the range of possible lengths for the third side? Well, if it's 4 inches plus 7 inches, that gives us 11 inches. So that means that the third side must be greater than 11 inches. So let's let the third side equal x. So the measure of the third side. X has to be less than 11 inches because these two sides have to add up to a number that's bigger than this third side, which means x cannot be less than or equal to, x must be less than 11. But let's look at this a little bit further. X has to be less than 11, but what does it have to be greater than in order for the other possible options to work? So in other words, 4 plus x has to be greater than 7, and 7 plus x has to be greater than 4. In order for the theorem to hold, it has to be true for everything. So 4 plus x has to be greater than 7. Well, if x is 3, it's not going to be greater than 7, and it's going to be equal to 7. So in this case, x has to be greater than 3, because if it's anything bigger than 3, even if it's 3.1 inches, it'll still be bigger than 7. Now in the other one, 7 plus x is greater than 4. Well, 7 plus anything is greater than 4, so that doesn't give us an additional restriction. But we do need to show that x has to be bigger than 3 inches but less than 11 inches in order for this to be a triangle.